Hello. Our aim in this problem is to find the antiderivative of the function 8x squared minus 2x times cosine of minus 3x. Let us integrate the function 8x squared minus 2x times cosine of minus 3x. See that, at the first glance we easily see that the function we have to integrate is a product of a nonlinear function, cosine of minus 3x, with a polynomial function 8x squared minus 2x. Sometimes, when you are faced with this type of complex integration problems, you have to adopt the appropriate strategy that will help you simplify the problem, and find the antiderivative efficiently. The two main techniques that we learn in Calculus 2, for solving integrals that involve the products or quotients of nonlinear functions are the U-substitution method and the method of integration by parts. The crucial first step of our strategy is to decide which of these two classical methods we should use. In this case, we have a product of a nonlinear function with a polynomial function, so the best method to use is the method of integration by parts. Because this method will help us reduce the complexity of the problem by reducing the degree of the polynomial. Observe that, the polynomial function 8x squared minus 2x is of degree 2. Therefore, our first goal will be to reduce the degree of the polynomial function to 1, by using the method of integration by parts. Let us briefly review the method of integration by parts. We know that the integral of u dv is equal to u times v, minus the integral of v du. Then, we set u equal to 8x squared minus 2x, so du equals 16x, minus 2 dx. Please do not forget to like the video and subscribe to our channel. Thanks. And, dv equals to cosine of minus 3x dx, and v equals to 1 over minus 3 times sine of minus 3x. Finally, the integral of 8x squared minus 2x times cosine of minus 3x dx is equal to 8x squared minus 2x over minus 3 times sine of minus 3x, plus the integral of minus 16x plus 2 over minus 3 times sine of minus 3x dx. Consequently, we still have to integrate minus 16x plus 2 over minus 3 times sine of minus 3x, using integration by parts. Let us integrate the function minus 16x plus 2 over minus 3 times sine of minus 3x. Given that the function to integrate minus 16x plus 2 over minus 3 times sine of minus 3x is still the product of a nonlinear function with a polynomial function, we still have to use the method of integration by parts. The main aim of these repeated utilization of the method of integration by parts is to reduce the degree of the polynomial function, minus 16x, plus 2 over, minus 3. Therefore, we set u equal to, minus 16x, plus 2 over, minus 3, so du equals 16 over 3 dx. And, dv equals to sine of, minus 3x dx, and v equals to, minus 1 over, minus 3 times cosine of, minus 3x. As a result, the integral of, minus 16x, plus 2 over, minus 3 times sine of, minus 3x dx is equal to 16x, minus 2 over 9 times cosine of, minus 3x, plus 16 over 3 over 9 times sine of, minus 3x, plus a constant c. Now we have to aggregate the results of these repeated applications of the integration by parts to get the final value of the antiderivative of 8x squared, minus 2x times cosine of, minus 3x. The first integration by parts gave the following result. So, the integral of 8x squared, minus 2x times cosine of, minus 3x dx is equal to 8x squared, minus 2x over, minus 3 times sine of, minus 3x, plus the integral of 16 over 3 over, minus 3 times cosine of, minus 3x dx. From the second integration by parts we obtain the following result. So, the integral of 16 over 3 over, minus 3 times cosine of, minus 3x dx is equal to 16x, minus 2 over 9 times cosine of, minus 3x, plus 16 over 3 over 9 times sine of, minus 3x plus a constant of integration c. Lastly, combining the last two results we see that, the integral of 8x square, minus 2x times cosine of, minus 3x dx is equal to 8x square, minus 2x over, minus 3 times sine of, minus 3x, plus 16x, minus 2 over 9 times cosine of, minus 3x, plus 16 over 3 over 9 times sine of, minus 3x plus a constant of integration c. Thank you for viewing this video. Please subscribe to our channel. We have an extensive collection of calculus videos covering limits, derivatives, series, integration, and many other calculus-related topics such as probability and differential equations.